Okay, good evening, everyone. So the first exam we're going to cover is the one from fall 2013, which starts with a case of a question about speciation. So the question is, in allopatry, so first of all, in the case of, can I draw? Yes. So first of all, just to make sure, so what is allopatry? Can anyone tell me what was the allopatry? What is the definition of allopatry vis-a-vis speciation? Anyone? So what is allopatry? Geographic separation. Christine says geographic separation. Absolutely correct. So the idea is that there is no gene flow. So no gene flow. No gene flow, meaning that there's no migration. So allopatry is no gene flow. The idea being that as two populations are in two different locations, individuals from one population cannot migrate. So if if the geographic locations are choice. Okay, how about so can everyone hear me now? Is okay? Yes. Sorry, there was a sudden uh, uh, refresh of this entire web page for some reason. Who knows? Who knows where to lay the blame? Now, as I was saying in allopatry, so the question one from 2013, in allopatry, the males of two species both have a red head stripe, which the female used in species occur together. One species lacks the red stripe. Instead, males have a red patch on the breast. Females select males on the basis of the red patch. Is the blank is likely to have produced this phenomenon: reinforcement, character displacement, character divergent, reproductive isolation, ecological divergence. So in your view, what is the problem? What is the reason? So we have a species A and species B. So where they meet, so in the point of contact, instead of using the red stripe, which both species use, otherwise for mate choice, they use a red patch on the breast. So what type of scenario is that? So first of all, A, reinforcement, maybe. B, reproductive character displacement, maybe. So these two are, A and B are plausible. Character divergence, that's not relevant. Reproductive isolation, again, not relevant. Ecological divergence, not relevant. So the question is it uh, is reinforcement cause of this situation, or reproductive character displacement is the cause of this situation in your view? So is it reinforcement or is it reproductive character displacement? Anyone? Any preference on if it's reinforcement? So, apparently no preference. Well, I would say that the reinforcement actually is this so it's characters are displaced. I'm actually not sure if okay, it's actually very likely to be reproductive character displacement, because there are characters that are used somewhere else. So when the species don't meet, they don't have those characters. When they meet, they have these characters. So it's likely to be reproductive character displacement, unless you have a better argument on reinforcement to be the case. Because reinforcement, I would usually assume it's going to affect the reproduction as species come to contact with each other. In this case, that's not the case. All right. Question 2. Based on the phylogeny shown below, oh no. Okay, shown below, what is happening? Shown below, which of the following statements is true? Human evolved from chimpanzee. Human evolved from apes. Human evolved from chimpanzee. Chimpanzees evolved from humans. Humans and chimpanzees evolved from gorillas. Human evolved from monkeys. Okay, so the group they're talking about is apes and humans. So this is the group they're talking about. So some of these answers are obviously wrong. Chimpanzees evolved from humans. That can't be the case. Humans and chimps evolved from gorilla. A living species didn't evolve from other living species. That's the whole point of phylogeny. So that can't be the case. Humans, chimpanzees, that can't be the case. Did human evolve from apes or human evolved from monkeys? So if you were to consider human evolving from monkeys, so monkeys are a different group that have evolved. So whatever common ancestor existed resulted in apes and humans, and then two types of monkeys, New World and Old World. So humans evolved from apes then. So A seems to be the correct answer. Okay, let's go to question 3. The phylogeny below shows the evolutionary relationship among 7 species of wood warblers. Males of the striata and so let's actually track it. So D striata is here. A high frequency trill to the end of their courtship song. So it's H. Female D striata prefer male which males with trill over males whose song lacks the trill. If the female preference is a result of a pre-existing bias, which of the following is true? So they have which phrase in their song understand that and prefer that phrase at the end of it. So the question, if it is a pre-existing bias, so pre-existing bias simply meaning that character existed before. So females had that predisposition in the past, in the ancestral forms, and males later utilized it. They tried to bias. A. Males of D and D fusca should all form the trill. So D dominica, D fusca, there are these two. So this the cross is show the point where the common ancestor of striata, fusca, and dominica existed. So it says males of dominica and fusca should also perform this trill. That's not the case. So if it's a pre-existing bias in females, it doesn't mean that males also going to utilize it, unless we can prove positively that males exploit that bias. That A can't be the case. B. Females of D dominica and D fusca. Okay, this seems plausible. C. Females of D dominica, D fusca, but not of D cerulean and D nigris should prefer trill. Females of D cerulean and nigrescens are these two. So the circle the taxa descent from the circle shouldn't prefer it. So females of Dominica di Fusca as cerulean and nigrescens should prefer it. Only females of Astrata should prefer the trill. The idea being that if it's a pre-existing bias, we only can go as the most common ancestor, which shows the common ancestor. Fusca, Dominica, and Striata possibly had that pre-existing bias, or not. So what we can say, given the information, is that the females of those two species should also prefer it if it's based on pre-existing bias. It might be a pre-existing bias in all these taxa, but we can't say for sure given the information we have. All right. So 4 is not relevant yet. 5. A critical missing component in understanding of how life evolved is why prokaryotes evolved before eukaryotes, exact composition of the atmosphere of the early Earth, what compounds could be synthesized abiotically, a self-replicating molecule, What caused the Cambrian explosion? So a critical component in our understanding of how so prokaryotes evolved before eukaryotes is actually easy to explain. What compounds could how it could self-replicating RNA molecules, we know how that's the case. So it's between B and C. So B is something we don't know. I mean, question, but it's not critical now how life evolved. There are possible explanations of Cambrian explosion, but the exact composition of atmosphere of the Earth, that is of some debate. Which of the following must be true? First of all, anyone remembers what was the idea of an honest signal? So what is an honest signal as far as males are concerned in sexual selection? Anyone? Does anyone remember? So what does this? So what is this? What is an honest signal? So the opposite would be a deceptive signal, a dishonest signal, right? So what is this honest signal really? You can just type your answers and guess as well. Like don't be afraid uh, of suggesting some plausible definition. Even if it's wrong, it's much more preferable as scientists to just come up with possible explanations. Joseph has trait that evolve which affect behavior. Well, it is a trait and it does affect behavior, but can it be a bit more specific? So the question is, how can a signal be considered an honest signal? Billy says isn't energetically costly. So Billy is actually right. I mean, he's wrong, but he's right as well because honest signals are signals that are energetically costly. They are energetically costly. The idea being that it's very hard to fake a signal if it's very hard to create that. So if the signal is some sign that shows you are healthy, you're athletic, what have you. If in order for you to have that signal, you need to you need to have spent a lot of time trying to be healthy and not getting different types of um, diseases and such. To have that signal is an energetically costly process, so you can't really fake it. So that's the idea, as opposed to signals that can be faked. So if the signal is just a song, you can fake that, and that's not a problem at all. Okay, so in order for male threat to be considered a non-signal, which of the following should be true? So males must be able to punish cheater males. Sons must benefit more than daughters. So B is not the case because that's not really what it's about. Trade must be energetic cost to produce, which I just said. Um, what? Females must use several male traits as cues. All of the above must be true. So all of the above can't be true because actually, yeah, all of the above can't be the case because it must be true. In the case of cheaters, cheating is based on where it's not about honest signals. Uh, and D is not necessarily the case because if it's an honest signal, females can just use that one signal. So C is true. So again, honest signal is simply an energetic signal that is very hard to fake, and thus is pretty useful in determining if someone has a trait that you're interested in, if they possess the signal in question. Okay. Joseph says, would dishonest signal be used for predation? Yes, absolutely, right. Deception is part of uh, predation. It is, if any of you have ever watched a nature documentary, um, preferably BBC documentaries, they show a lot of predators who use different methods to deceive praise, and in those cases, those are dishonest signals, evolved to be dishonest so that they can deceive uh, the praise as they fall into a trap or they are caught unaware as they're being haunted by these predators. So thank you, Joseph, for suggesting that. That's exactly what it is. Um, all right, I'm not going to do question 7 because it's kind of weird. I probably go over question 7 later in the physical, uh, the non-virtual class, because it's hard to explain it without a whiteboard, a real whiteboard. Reorganization of the genetic architecture is characteristic of okay, vicariance, speciation, uh, founder event speciation, ecological speciation, and parapatric speciation, or speciation through hybridization. Just to remind you what they are, vicariance is you have ancestral species, so this one circle. Something happens, like you have, or they migrate to new geographies, so you end up with one population in one place and another population in another place, roughly the same size, and that's vicariance. So in the case of founder event, you have the same ancestral population, so I'm using green to show the founder. You end up with one tiny population splitting from the ancestral population. So the ancestral population keeps evolving, stays the species that it is, or becomes a new species through evolution and adaptation. The green one also becomes a new species. It's a founder event because you had a few number of organisms establishing the new population that eventually um, turned became the new species. Ecological speciation is where you have the species, so the same as vicariance, but they go to not only they go to two different geographies, they go to two different ecologies. So they are in new ecological niche with new environmental factors, and that's why they adapt and become different. Parapatric speciation is when you have populations that that have a point of contact, so you have some semblance of gene flow between the populations. So these two circles, there is a point where they meet, and that's where they have gene flow. And that is parapatric because it's not allopatric, so they're not totally separated. It's not sympatric because they're not literally in the same place. They are in different places, but they have a uh, they overlap to a certain extent in some areas. Speciation through hybridization is exactly what we are looking for, which is the reorganization of genetic architecture. It happens a lot in plants where you have a new species. So you had parents that were parents that were 2N, and they produced a hybrid that has 4Ns through some mistake, and the hybrid cannot mate with the parents. So the hybrid becomes a new species. So this 4N becomes a new species. In plants, you have a lot of these cases because they are more resilient to genomic duplication than animals. Uh, 9. Which of the following is an example of sexually antagonistic coevolution? Male red deer with high mating success have sons with high reproductive success. Male red deer with high mating success have mate with females that have high reproductive success. So B is already not the case because that's what every organism does. Female red deer with high fitness have daughters with high reproductive success. Female red deer with high reproductive have sons with low reproductive success. Male red deer with high reproductive success produces sons with low reproductive success. So in order for it to be sexually antagonistic, it should affect different sexes or different sexes in ways that are obviously antagonistic. So, for example, mothers should have effects that are bad for sons. Fathers should have effects that are better for sons but bad for um, daughters. So, in only case where you have a flip, so you have one sex affecting the other sex in a negative way, is D when you have females that producing low mating sons with low mating success. In all the other cases, you have males uh, uh, affecting the reproductive success of their own sex, females affecting daughters, and so the only case that is antagonistic between sexes is females affecting the fitness of sons. 10. Which of the following mutations is consistent? Oh, sorry, this one I think you haven't really arrived at that point yet. So let's move on to 11. Which position on the phylogeny below correctly represents our current view of the last universal common ancestor? Is it D, is it C, is it B, or is it A, or is it none of the above? So which one is the last universal common ancestor? So I'm assuming the X's in this tree, they represent lineages that arose and just disappeared. The three main branches that are represented are the branches that encompass all the organisms that we know of. So you have these, for example, archaea, bacteria, so the three domains of life, and eukaryotes. So which one is the last universal common ancestor? Is it D, is it C, is it B, or is it A? So anyone? So the last universal common ancestor. You can just type your answer. Is the last universal common ancestor A? Is it B? Is it C? Or is it D? Anyone? D, yes. Joseph says D. He is right. So this one is the last universal common ancestor of the branches that resulted in all the organisms that we know of. And because it's like you're looking at the living organisms and constructing a tree, they're all related. As you go down the tree, you reach a point where all of them are related, and that's last common universal universal common ancestor. 12. In lions, when a new male takes over a pride, he kills all cubs that are present. Without a cub, females are receptive to mating. This is a possible example of, is it cooperation? Is it altruism? Is it spite? Is it selfishness? Is it none of the above? What do you think it is? So surely, lion killing all the cubs is not cooperation. Like lion is not cooperating with anyone in this case. It's not altruism, because altruism, the idea is that you behave in a certain way that obviously doesn't directly benefit you. In this case, lion killing the cubs makes the females receptive, so it directly benefits him to kill the cubs. So it's not altruistic. Spite is not a spiteful behavior because it's not in response to something else, but it is a selfish behavior because what the lion wants is to have females that would mate with him, and as long as females have kids and there's pride, they won't accept mating again, and so the lion it just goes around, kills all the cubs, and then females would mate with him. All right. So in Colorado, the Rocky Mountains separate the plains of Front Range from the deserts of the western slope. Many species, so F and W, F represents front slope, so front range, and so front range is F, western slopes W. Many species of this Oxytropis occur on only one side of the mountains. Which of the phylogeny is shown below is consistent with the Vicarians speciation in local weeds? So Vicarians again was the case where you had ancestral population split into two different geographies, and so they end up being in two different geographies. And the species are geographically separated from each other. So which one shows a speciation where? So in let's look at A. So in A we had a speciation event here. So that from left to right we had here, which is resulted in W1 and F1, so one from mountain, one at the front slope. Again, here the same thing. Here again, when you had a speciation, you had one that is in western slope, the other one is front range, and the same thing here. So in B, so all these groups are, so speciation happened, they are all in the western slope. Here they are all in front, these are in front as well. Again, western slope, front as well. So they're clustered across, so you have this group, all of them are western slope, this group, all of them are front. Here again you have all of them western slope, and all of these front range. In C, it's the same story. You have clusters of western slope or front range variants, and on D, the same as well. So given this, which one is consistent with vicariance? I mean, even if you didn't know about what vicariance is, based on the fact that B, C, and D are consistent, shows that, and A is the only outlier, A should be the answer to this question. And the idea is that every time the speciation event happens, it happens through vicariance, so they have to either go to one geography, in this case, front range or western slope, and so if they one species goes to front range, the other species would be in western slope, and so they evolve and adapt independently in two different geographies, hence producing two different species with reproductive isolation by the end of the process. So that is the reasoning behind the behind having a tree, phylogenetic tree with branching points, resulting in a species that are that belong to one geography or another. Okay, female dragonflies mate with male and then oviposit, lay eggs on aquatic vegetation within his territory. During copulation, the male removes any sperm already in the female's sperm storage organ. After copulation, the male guards the female while he's ovipositing. Based on the male behavior, which of the following is unlikely to be true? The female mates with multiple male. The female will mate with multiple males. Uh, Offspring that develop on the male's territory will not be his. The female chooses mates on the basis of territory equality. Female receives a direct benefit from mate choice. Selection will favor males that can completely remove previous sperm deposits. So E is, of course, correct, right? But the question is which one is unlikely to be true? The female mates with multiple males. That is, of course, that should be the reason for this behavior. The female chooses mates on basis of territory equality. This is not. C is not necessarily obvious from this explanation. But also B. Oh, okay, so the upper vegetation. Oh, within his territories. Okay, so that's. So I think then, okay. So if it's his territory, then C and D also should be correct. So then it's B that is incorrect, which is offspring, because since the behavior is that he's trying to get rid of all the sperms in the sperm storage organ within the body of the female, it stands to reason that most of the offspring should be his, given that there are probably only a few sperms left that are not his. Well, why do Homo sapiens, Homo neanderthalensis share DNA if not from common descent? Do we know that? Have we reached that point? The human evolution is not yet has yet to be covered. So, is there any other question here, or should we move on to the more recent? I think we have to move on to a more recent question or exam. So the next one is going to be from 2014. So the third exam, and you would notice that some of the questions actually are the homework questions, so we are not going to cover those. So let's just check if the first one is done. Okay. So which of the following hypotheses about adaptation must be tested with comparative method? So comparative method is a method where you take into account the phylogeny. So you don't simply look at the adaptation, you also take into account the relationship between species, which you have been studying as well, to see what is the pattern of adaptation, if it's about common ancestry or not. So during Pleistocene, a rapid increase in the brain volume of herbivores led to an increase in the brain volumes of carnivores. King's snake, which mimic poisonous coral snakes, suffer fewer attacks from predators. Flowers with petals that mimic female bees have higher rate of pollination than flowers which lack such petals. Male red-black spiders that allow themselves to be eaten by female spiders after mating father more of her offspring. Male red-shouldered widowbirds with longer tails will have a higher mating success. So C and D and E are obviously not what we're looking for. So in B is king snakes, which mimic poisonous coral snakes, suffer fewer attacks from predators. I mean, it's an adaptation, but and it's mimicry, so I'm not sure if that's the case. Flowers with petals that mimic female bees have higher rates of pollination than flowers which lack such petals. during processing a rapid increase in the brain volume of herbivores to an increase in the volume of carnivores. So in the case of, I think, I mean, C seems to be the most plausible question because this one is a lot of flowering plants. The question is if there is any relationship between, if the signal is compounded by the relationship between those species or not. But A is also kind of interesting. So I would probably go for B, but A can be the case as well. I'll probably check that before our next recitation. For reciprocal altruism to evolve, all of the following are necessary characteristics. So reciprocal altruism is where you do something for someone, but you get something in return as well. So recipient must have the opportunity to reciprocate later, so that is necessary. There must be some way to detect and punish cheaters, yes, because it's reciprocal. It's not just about relatedness. It's not about relatedness, actually. It's just simply about tit for tat. The benefit of receiving help must outweigh the cost of giving help. Some degree of relatedness, which is also not necessary. All of the above are not necessary, so C is the correct answer. I don't think 4 is, you haven't reached that yet. 5, in allopatry, which we explained earlier, the males of two species of fish both have a black and silver tail spots, which the female used in mate choice. Where the two species form together, black silver, one species lacks the black and silver tail. Instead, males have black and silver so posterior to the eyes. Females make the base of the black and silver spots. So in this case, it's a very similar question, and it is the reproductive character displacement that happens where two species meet. So in the area of overlap, the characteristics that would naturally be used for sexual selection, they are no longer useful because the other species also uses the same thing. So there's selection for reproductive characters to be displaced, so that you would lower the probability of hybridization between species, which is the major concern of selection in that case. Okay, 7 is not necessarily, you haven't reached that. Okay, this one is not. Okay. This one is not from, is it? This one is not from homework. So you have selected one population, you have selected on populations of Drosophila melanogaster to increase or decrease male fertilization success and to increase or decrease female fecundity. You make all possible crosses between your 4 selected lines, high and low female fecundity, and high and low male fertilization success, and measure the performance of males and females offspring. Interlocus conflicts. So which one shows antagonistic, sexually antagonistic traits? So the ones that we are looking for should so we are crossing. So let's start reading the plot A, analyzing it. So in plot A, from left to right, the first two columns are high male and high female, right? And they produce. So black bars are sons or females, and the white bars are female. White bars are females, so black ones are males. So in A, you had high male, high female. They are roughly the same. You had high male, low female. you ended up with high male and low female, so that was the same. You had low male, high female. You produce. So the next generation is also low male, high female. Low male, low female produce the same thing. It's slightly more males than more successful males than females. So the other one was high male, low female here. So high male, high female, again, they're the same. Low male, low female, they're the same. Low male, high female, they're what you would expect. So in B, they reflect what the parents are. In C, you have high male, high female. You get high male and high female and low females. In the case of high male, low female, you get high male and low female. In the case of low male, high female, you still get high male. Low male, low female, you get, again, males are higher. So in the case of the last one, D, you have high male, high female, you get slightly more females. High male, low female, the same. Low male, high female, you get more females. Low male, low female, you get roughly the same. So which one is the case? So I think A is the most likely to be the case, because as you can see, when you have high male, low female, in cases they are the most drastically affected by the parental. So you have more difference between the outcome than you would here in B and in C and certainly in D. All right. So question 10, which of the following is unlikely to be altruistic action? Helper scrub jays defend the net from predators such as snakes, lowering their survival. Sentinel meerkats spend time watching for predators instead of feeding. Young acorn woodpeckers remain on their panther instead of dispersing. Foraging by primary helpers enables breeding pair of. So D is, so let's go. So D is obviously an altruistic behavior, because foraging by primary helpers, they're just helping their fellow kingfishers. E, by feeding the young non-breeding Arabian babblers, reduce the time of breeding pair. Again, this is probably altruistic. As A, helper crabjays defend the nest from predators and snake, lowering their own survival. So that's probably altruistic as well. Sentinel meerkat spend time watching for predators instead of feeding. Is also possibly altruistic. C, young acorn woodpeckers remain under panther territories instead of dispersing. That is not necessarily, that doesn't really sound like an altruistic question or altruistic behavior. So C is the correct answer. Which of the following is an example of Haldane's rule? So G.B.S. Haldane, biologist, British biologist from in the first half of 20th century. And the Haldane's rule is generally described as the fact that in hybrids, the hybrids that are hemizygotic, meaning that they have half of the sex chromosome. So in us, those are males that are hemizygotic because they have X and Y. So the hemizygotic sex is going to suffer more sterility and viability than the normal sex. So Females are going to be fine, but males are going to be more messed up, sort of male hybrids, that is. So which is an example of that? In the hybrid between blue-backed and golden poison dart frogs, egg-sperm incompatibilities lead to complete reproductive failure. But that doesn't really tell us anything about Halden's rule. The hybrid offspring of the glossy firefinch and the sedate firefinch are unable to feed on the seed used by either parents. That's just extrinsic postzygotic barrier. B has nothing to do with Haldane. Hybrid offspring of bull and spotted weevil die as embryos. Again, that's just incompatibilities. Hybrid offspring of white-footed and plain deer mice are able to occupy a habitat that can't be used by either present. That's just hybrid vigor. E, in hybrids between Drosophila mauritiana and Drosophila jacoba, males do not sing the species with the courtship song and are unsuccessful at mating. So that is Haldane's rule, because males are, in this case, with an extrinsic postzygotic problem, so the hybrids cannot mate, and so they are, for all intents and purposes, low fitness, because they are as good as dead fruit flies since they can't mate. I mean, biological sense, that is. 13. Which of the following does not support the hypothesis that all existing life on Earth had a common ancestor? RNA as universal information storage molecule, arbitrary but nearly universal genetic code, universal translation machinery, ribozymes, utilization of D-isomer sugars, L amino acids. So the only one is the C, because a universal translation machinery, those are not ribozymes. Those are proteins. So this is wrong. This is not an evidence of anything. 14 is not yet related to what we have covered. 15, the biological species concept applies to which of the following species? Homo sapiens, Homo neanderthalensis, Homo ergaster, Homo erectus apply to all of them. The difference between so can you spot the difference between Homo sapiens, Homo neanderthalensis, Homo ergaster, and Homo erectus? Can you spot one major difference between these four species? Anyone? Just type your answer. So, is there a major difference between Homo sapiens and the other three: Neanderthalensis, ergaster, and erectus? Just type which one. Yes, so Joseph says this is the only one that's still alive. Yes. So Homo sapiens is the only one that's alive. Biological species concept does not apply to fossils, and that's why it doesn't apply to the rest. 16, for the phylogeny given below, how many independent contrasts are available? So independent contrast points are just common ancestors. So here we have 1, 2, 3, 4, 5, 6, and 7. There are 7 points there. So simply where bifurcation happens on the tree. So female 13-banded ground squirrels breed once a year. During the breeding season, females mate with several males, sometimes repeatedly. This behavior is best explained as females change their preference when given many choices. Well, that doesn't make any sense. Female survival is increased by multiple mating. Female fitness increased by allowing sperm competition. Multiple mating allows the female to forage on multiple territories. Females are unrelated to males in their social group, so E also not relevant. Female survival is increased by multiple mating. That doesn't make biological sense. So we're between C and D. Sperm competition doesn't really help females, but the idea that they would forage on multiple territories, that would be a main thing. So D is the correct answer here. 18, nepotism is defined as, everyone knows what nepotism is, especially these days. So even the common definition would suffice, which is directing help to relatives. So 19 is not relevant to what we're doing. Which of the following is most likely to represent incipient ecological speciation by disruptive selection? A guppy population. So ecological speciation meaning that they go to the two populations are in two different environments and they adapt to those environments, and that adaptation, because the environments are different, results in divergence between them. So we have to find one case when you have two different environments. So a guppy population separated onto the island of Trinidad, mainland Venezuela, due to the rise of sea levels at the end of Pleistocene glaciation. Population of honey creepers colonized recently from island of Hawaii, from the older island of Maui. Population of bluegill sunfishes in both near shore and deep water habitats in a pond. A population of tulip poplar separated by advancing glaciers. A population of mosses that has colonized recently from island of Surtsey, Iceland. So the only one that talks about two different ecologies is a population of bluegill sunfish using both near shore and deep water habitats in a pond. So the idea is that eventually they're going to diverge, like those that are in near shore and those that are in deep water, and that would result in divergence. All right, so that's the end of this exam as well, and that's the end of today's session. Anyone, if you have any question before we conclude, please type. If not, we can just leave. Have a great Saturday, and see you on Monday. I'll probably post something to tell you if we will have an online recitation next week. So in Thanksgiving week, because I'm not sure if people will be around for that. So just I will post something if I were to